All right, how's everyone doing? Happy homecoming week. Today we're going to get crazy mathalicious on you. All right, we're going to start solving systems of equations with not two variables, but this time we're going to have three variables. So we're solving with x, y, and z. We started thinking like this tomorrow, and today we're going to take it a step further. So please take notes, because this is going to be your blueprint to solving in class on Friday. So take a second, set it up, and then we'll get going. All right, now, notice we have three equations, three variables. For reference, I'm going to call this first equation, equation A, second equation, equation B, and third equation, equation C. This is because as we scroll down and we begin to show our work, we're going to need a reference. So if I say equation A, I'm referring to the first one, B the second, so on and so forth. So our first step in this process is we need to choose two equations. So choose two equations and eliminate one of the variables, so a variable. All right, so we need to eliminate one variable. So looking at this, let's kind of focus on equations A and B for right now. All right, if I were to have to eliminate one variable in there, I would probably choose y, because we have a positive 2y and a negative y. So I would take equation A, which is 3x plus 2y plus 4z equals 11. And then I would have to multiply this whole equation, equation B, by 2 in order to create a negative 2 on the y. So to exemplify that, I'm going to put 2b. So that means we multiplied equation B by 2. And when we do that, we get 4x minus 2y plus 6z equals 8. All right, so we got to multiply everything by 2, just as we would in regular elimination. So then when we add those two together, my y's, I get 3x plus 4x, which is 7x. My y's are eliminated. I get 4z plus 6z, which is plus 10z, equals 19. All right, now I'm going to highlight that equation. You may want to circle it. And we're going to come back to it. All right, but for right now, we're going to leave it as is. Now, our second step is now we need to take our third equation, which is equation C, and we're going to pair it with another one. So we need to pair the third equation with another and eliminate again. Now, the most important piece here is when we take equation C and we pair it with another guy to eliminate, it's imperative that we eliminate the same variable. All right, this is the most important part of this whole process. When I mean the same variable is that we eliminated y. So in this case, we absolutely positively have to eliminate the variable y. In the event we eliminated the x's, we would pick on the x's. So let's start with my third equation. So we have equation C, which is 5x minus 3y plus 5z equals negative 1. So you can pick A or B, it doesn't matter. I'm going to pick B. Because again, on the y's here, I would have to multiply by negative 3 to get rid of that. So I'm going to take negative 3 times equation B. So I'll multiply everything in equation B by negative 3. So that gives me negative 6x plus 3y minus 9z equals negative 12. Now apply your elimination here. So 5x plus negative 6x is negative x. My y's eliminate. 5z plus negative 9z is negative 4z equals negative 13. All right, now that's my second equation. So now what we've done is we've created two equations with only x's and z's. We've eliminated the y's. So now step 3 is we're going to use our two resulting equations from step 1 and step 2, and we're going to solve another system. So step 3 says use equations from step 1 and 2 and solve the system. Alright, so my first highlighted equation is 7x plus 10z equals 19. And my other one is negative x minus 4z equals negative 13. So now we'll use what we know about solving systems of equations and solve that one. So I'm going to multiply the bottom equation by 7 to eliminate my x's. So I have 7x plus 10z equals 19. Then down here I multiplied everything by 7. So I got negative 7x minus 28z equals negative 91. My x's are eliminated. And I have negative 18z equals negative 72. Divide both sides by negative 18. And z is 4. Alright, now let's substitute z back in and solve for a piece. I'm going to do the top equation. So we have 7x plus 10 times z equals 19. So I have 7x. I'm sorry. Z is 4. So 7x plus 40 equals 19. So 7x equals negative 21. Divide by 7, and x equals negative 3. At that point, again, we can use any equation. So now we have x and z. So now we have to find y. So let's go back up and let's just use equation A. Alright, so find third variable. And this is just equation A. And equation A said 3x plus 2y plus 4z equals 11. Again, this is referenced from the top of the page, the beginning of the notes. Right? And we know, we said x is negative 3, z is 4. So we have 3 times x, which is negative 3, plus 2y, because y is what we're solving for, plus 4 times z, which is 4, equals 11. So negative 9 plus 2y plus 16 is 11. Gives me 2y plus 7 is 11. 2y equals 4. So y is 2. So the solution to my system of 3 variables is negative 3 is x, y is 2, and z is 4. And we did all that work to get that answer. All right, now the final step is step 5. Again, you can always check your solution. Okay, so you could go back and substitute it in equation B or equation C, it doesn't matter. Let's just do B. 2 times negative 3 plus, minus y, which is 2, plus 3 times 4. Does that equal 4? Negative 6 minus 2 plus 12. Negative 8 plus 12 equals 4. Done. Alright, it checks out. So we did something right. Okay, please bring your notes tomorrow because we'll have 2 problems we need to complete in class, and then we'll have plenty of time to get started on our homework for the weekend. Enjoy your evening.